Welcome to the lesson on multiples. When we think about exploring numbers and how numbers can get smaller, we also must examine how numbers get bigger and what happens as we add and multiply numbers. Let's think about a basic definition. A multiple of a number is the product of that number and another number when multiplied. If you think about 3 times 6 and how it equals 18, the number 18 is a multiple of 3 and of 6 because it took those two numbers multiplied to get 18. So we think about how we think about notations and we imagine 3 and 7 and all their multiples. 3, 6, 9, 12, so on and so forth. We look at 7, 14, 21, and we notice that 21 is a multiple of both numbers. 21 is now the least common multiple of the number 7 and the number 3. So how do multiples apply to real world? Well, we think about going to a barbecue and trying to buy a bag of buns and a bag of burgers, and them coming in packs with different amounts of each product. So how do we ensure we purchase the right amount so we don't have anything left over? Let's take us into our first example. Take the amount that I have in each bag. 6 buns, 4 burgers, 6 times 4 is going to give me 24. I will take both of my factors in this basic multiplication problem and find their factors. 2 and 3 for 6 and 2 and 2 for 4. And then I'm going to see, do I have any common factors that I'm able to quite possibly cancel out? And I do. This 2 over here with the 6 and the 2 over here with the 4 easily cancels out, and 2 becomes our greatest common factor. So then I take the number 24, since that was their product, divided by the greatest common factor to give me 12, the least common multiple, which I can also explain as the smallest number that both of those factors will both go into. Let's think about another example and say barbecue oriented. Let's say I have a pack of 8 hot dogs and a pack of 12 buns. How do I buy the appropriate numbers in order for me to make sure I don't have anything left over? Make it a basic multiplication problem. 8 times 12 is going to give me 96. I'm going to keep that 96 off to the side. And let's find the factors of both of my factors. So 8 is going to be 4 and 2. The 4 breaks down into 2 other 2's. Same thing with the 12, 4 and 3. And the 4 breaks down into 2 other 2's. Now, do we have pairs between our factors? This time around, we definitely do, as I can match up a 2 with the 2 from the 12 and another 2 from the 8 with another 2. So to find the greatest common factor, I'll multiply the 2 times the 2, and I'm going to get 4, which I will then take 96 divided by that 4 to give me my least common multiple of 24, which means 24 would be the magic number to buy of each hot dogs and of hot dog buns to make sure I have nothing left over. 24 is my least common multiple. Let's take a look at another example where the numbers might not have the same kind of things in common. And let's look at 8 and 15. I will start by multiplying these two numbers and getting a product of 120. After that, I'll go to find the factors of each of my factors. So I find my factors of 8, and I'll get 4 and 2. 4 breaks down into 2 other 2's. And the factors of 15, which are 5 and 3. Now what I notice here is that there's not any 2's that match up with any of the 5 or 3's, and there's no 5 or 3's with the 8 that match up either. So there is no common factor between the 8 and the 15. What this tells me is that our least common multiple between 8 and 15 would end up being 120. And in this case, although it's a big least common multiple, it is indeed our correct least common multiple. So in establishing a connection to the real world, least common multiples can help us figure out with area, as well as give us the capacity to count vast quantities to figure out how to maximize our efforts.